I'm gonna bring me Luther. Can you be my tutor? We want to feel like tutor. Can you be my tutor? We want to feel.
Hello everyone, I hope you're all doing well. This is your favorite tutor. In today's video, we want to see how we can find the maximum profit using quadratic functions in Math 1110. So without wasting much time, let's jump straight into it. So the questions that we're going to be looking at today are question 3, which is the cholera question, and question 4, which is the profit function question. But before we can actually begin, it's important to understand what a quadratic function is. A quadratic function is a function which is written in the form ax squared plus bx and plus c, where a, b, and c are all real numbers and a is not equals to 0. This is what a quadratic function is, and it's important to know that whenever we graph a quadratic function, it forms or it creates a U-shaped curve known as a parabola. Now, this U-shaped curve can either open upwards or it can open downwards. The thing that determines whether this U-shaped curve opens upwards or downwards is the sign in front of the coefficient of x squared, which is a. Therefore, if the sign in front of a is negative, then the graph of our quadratic function is going to open downwards. However, if the sign in front of a is positive, then the graph of our quadratic function is going to open upwards, or rather it's going to be U-shaped. Either way, they are both U-shaped, it's just that one is facing upwards and the other one is facing downwards, depending on the sign of a. Another way of looking at it is that if a is greater than 0, then our graph is going to open upwards. However, if a is less than 0, then our graph is going to open downwards. So what we have up here and what we have down here is just one and the same thing. When a is less than 0, we know that this is a negative number. However, anything that is greater than 0 is positive. So if your a is greater than 0, then your graph is going to open upwards. So this and that are one and the same thing. This and that are one and the same thing as well. Another thing that we need to take note of before we can proceed to answering our questions is the concept of the vertex. So the vertex is the highest or the lowest point of the graph of a quadratic function. In the case where the graph of a quadratic function opens upwards, the vertex is going to be the lowest point right here in the middle. However, if the graph of a quadratic function opens downwards, then the vertex is going to be the highest point, which is this part right here in the middle. So if the graph opens upwards, the vertex is the lowest point, and this lowest point is known as the minimum point. On the other hand, if you've been given a quadratic function, but the graph of this quadratic function opens downwards, then the vertex is going to be the highest point, and this highest point is known as the maximum point. And as we know, every graph is going to have an x-coordinate and it's also going to have a y-coordinate. Now, the vertex, which can either be the highest point or the lowest point, also has its own coordinates. Now, the x-coordinate of the vertex, whether it is the highest point or the lowest point, is represented by the letter h. And the y-coordinate of the vertex, whether it is the highest point or the lowest point, is represented by the letter k. To summarize everything, the vertex is given by the coordinates h, k. So these are the two coordinates that give us the vertex. Now, it's important to ask ourselves why the vertex is important to us answering our questions today. Recall that the vertex is the highest or the lowest point of the graph of a quadratic function. Therefore, when answering questions that ask us to find the minimum point of something or the maximum profit of a company, it's important for us to know what the vertex is, because the vertex is that point that gives us the lowest point of something or the highest point of something. So the vertex can tell us what the minimum value of something is or what the maximum profit of a company is. This understanding of the vertex will help us answer our two questions today. Now, let's move on and begin answering our two questions. Alright, so we're going to begin by looking at question 3. And question 3 here reads, the number of Vibrio cholerae in refrigerated water is given by n of t is equals to 20t squared minus 20t plus 120 for the domain -2 is less than or equal to t and t is less than or equal to 14, where T is the temperature of water in degrees Celsius. Then we've been asked to find A, the number of bacteria at 0 degrees, B, the number of bacteria at 10 degrees, and C is asking at what temperature will the number of bacteria be minimal. So let's start answering our question. We're going to start by writing down our quadratic function, which is n of t, which is equals to 20 t squared minus 20t plus 120, and we can see what our domain here is. And from this quadratic function, we can see that our a here is 20, our b is negative 20, and our C, which is our constant here, of 120. So we have our A, we have our B, and we also have our C. So we're going to start with question 3a, and question 3a here reads, find the number of bacteria at 0 degrees Celsius. Now, for us to find the number of bacteria at 0 degrees Celsius, we are simply just going to substitute 0 for t in our quadratic function, so that we have n of 0 is equals to 20 0 squared minus 20 0 plus 120. So all we have to do now is simplify this. When we simplify this, we are going to have plus 120, and everything is going to simplify to 120. So what this is simply telling us is that when the temperature is 0 degrees, the number of bacteria that we're going to have is 120. So at 0 degrees Celsius, the number of bacteria that we have is 120. B is telling us to find the number of bacteria at 10 degrees. So we're just going to substitute 10 degrees there. So we're going to have 10 in here, so n of 10. And then we're going to have 20 multiplied by 10 squared. And then we're going to have minus 20 multiplied by 10 plus 120. Then we're going to simplify this. When we simplify this, we're going to have 20 multiplied by 10 squared, and 10 squared we know that is 100. So we're going to have 100 there, and then we're going to have minus 20 times 10, which is going to give us 200 plus 120. When we simplify this further, we know that 20 times 100 is equals to 2000 minus 200 plus 120. When we simplify all of this, the final answer is going to be 1920. So when the temperature is at 10 degrees Celsius, the number of bacteria that we're going to have is 1920. This is what this means. Now let's move on to question 3c. Question 3c here reads, at what temperature would the number of bacteria be minimal? In other words, what temperature will give us the lowest number of bacteria? So this is what we have been asked to do. We know that our quadratic function is n of t is equals to 20t squared minus 20t plus 120. And we know that our A is equals to 20, our B is equals to negative 20, and our C is equals to 120. Now, when we look at A, we can see that the sign in front of 20 is positive. Therefore, A is greater than 0. And we know that when A is greater than 0, the graph of our function is going to open upwards. And when the graph opens upwards, the vertex is the lowest point of the graph. That's the vertex, the point in the middle of the graph. Now, in order for us to know the temperature that will give us the lowest number of bacteria, we need to know what the vertex is. Why? Because the coordinates of the vertex of this graph would tell us exactly the temperature that will give us the lowest number of bacteria. Here's another way of looking at it. Remember, the vertex is given by the coordinates h, k. So now we're being asked to find the temperature that will give us the lowest number of bacteria. So we can say T, our temperature, is our x coordinate, and our number of bacteria, n, is our y coordinate. And remember, when it comes to our vertex coordinates, we say that h is the same as the x coordinate and k is the same as the y coordinate. Therefore, in relation to question 3c, our temperature T is equals to our h coordinate of the vertex, and our number of bacteria, n, is equals to our k coordinate of the vertex. And when we are being asked to find the temperature which gives us the lowest number of bacteria, we're simply being asked to find h. And it is only when we know what h is that we can know what k is. Why? Because h is the input variable and k is the output variable. So when we find h, we're able to find k. And because the number of bacteria, n, is equals to k, finding k enables us to know the lowest number of bacteria, n. So in summary, when we find h, we are simply finding the temperature that gives us the lowest number of bacteria, k. Now that we have this out of the way, let's proceed to answering our question. Now, to answer our question, we need to find the vertex, because when we find the vertex, we know what our temperature is and we know what our minimal bacteria is. One way of finding the vertex is writing the quadratic function in standard form. A quadratic function written in standard form looks like this. F of x is equals to a parenthesis x minus h to the power 2 plus k. So this is how a quadratic function written in standard form looks like. And when we look at the standard form here, we can see that by the time we finish writing the quadratic function in standard form, we would have found our h and our k, which are the two coordinates that give us the vertex. So writing our quadratic function in standard form helps us find the vertex. And once we find the vertex, we know what our final answer is. So in order for us to find find the standard form of the function, we need to use the completing the square method. Let's do just that. So we're going to have n of t equals 20t squared minus 20t plus 120. Then we're going to factor out a, and remember a is equals to 20. In other words, wherever we see t, we're going to factor out 20. So in this case, we're going to have 20. So 20 into 20t squared is going to give us t squared. And then 20 into negative 20t is only going to leave us with minus t. Then we're going to close the parenthesis, and then we're going to write our 120. So the next step is to find the half of b, square it, and then add it and subtract it at the same time. So let's do just that. Remember that our b initially from our quadratic function is negative 20. But since we have factored out 20 from negative 20t, we have remained with negative t. That means that our b now is equals to negative 1. We can see here this is negative t. This is just the same as having a coefficient of negative 1. So we need to find the half of b, or the half of negative 1, square it, and then add it and subtract it at the same time. To find the half of negative 1, we are going to multiply negative 1 with half. When we multiply everything, it's going to give us negative 1 over 2. So we're going to say equals 20. And we have our t squared minus t. We're going to maintain that. And now the next thing will be to add the square of the half of b. In this case, our half is negative 1 over 2, or half itself, or negative half squared. And then the next thing will be to subtract our half of b, which is negative 1 over 2 squared. So we have found the half of b, squared the half of b, and we have added the half of b, and we have also subtracted the half of b. So this is how it would look like. And then we're going to close the parenthesis, and then we're going to add our 120 over there. So the next thing that we're going to do is simplify everything within the brackets so that it's not very confusing to us. So we're going to have 20. And then if we're going to simplify this, we're going to have to square everything on the inside. So we know that negative 1 squared is simply just going to be 1. And then 2 squared is simply going to be 4. So our final answer here is going to be plus 1 over 4. So what we have done here is basically just multiply the exponent 2 with everything on the inside so that we have negative 1 squared divided by 2 squared. And then we know that negative 1 squared is 1. And then 2 squared is basically 4. Okay, so if you were confused with how we got the 1 over 4, this is how we did it. So we're going to do the same thing with the other one here. Negative 1 squared is 1, is positive 1, and negative 2 squared is positive 4. But remember, we have a negative on the outside, so it's not going to be plus 1 over 4 like here, because we're multiplying this negative with everything on the inside. Our final answer here is going to be negative 1 over 4. And then we're going to close our parenthesis, and then we're going to have our 120 over there. Our next step now is to take this 1 over 4 that we are subtracting on the outside of our parenthesis here, so that we just remain with t squared minus t plus 1 over 4. To do this, we're going to multiply a, and we know that a is 20, by this minus 1 over 4 in order to take it on the outside, so that we have 20 minus t squared minus t plus 1 over 4, close the parenthesis, and then we're going to have plus 20 multiplied by negative 1 over 4 plus 120. So now all we have to do is simplify everything here. As we begin the process of simplifying everything, we can see that inside the parenthesis we have a perfect square, and this means that we can also rewrite this in a different form, which is much simpler. To do that, we're going to say 20t, then we're going to omit the minus t, and then we're going to move on to 1 over 4. However, we're not going to write 1 over 4 as it is, because recall that a squared value is just a number multiplied by itself. So 2 squared is simply just 2 times 2, which is 4. So what we are most interested in order to simplify everything here, is the number that we multiplied with itself in order to give us 1 over 4. If we look at what we did previously as we were solving our equation, we noticed that we multiplied negative 1 over 2 with itself in order to give us positive 1 over 4. So what we are going to write here is negative 1 over 2 and not 1 over 4. And then we're going to close the parenthesis, and then we're going to square everything. So t is the number we multiply with itself in order to give us t squared. In the same way, negative 1 over 2 is the number we multiplied with itself in order to give us positive 1 over 4. T minus 1 over 2 squared is the same as t minus 1 over 2 times t minus 1 over 2. So if we multiply this times this, it's going to give us everything that we have here in the parentheses up there. So this is why t minus 1 over 2 squared is a simplified version of what we had before. So I just wanted to explain this so that we all understand how we got to this simplified version. Now let's finish simplifying our equation. At this point, we have 20 multiplied by negative 1 over 4. So when we simplify this, it's going to give us negative 20 over 4 plus 120. If we rewrite this further, we're going to have 20 t minus half squared minus 4 divided by 20 will give us negative 5 plus 120. Therefore, our final answer in this case will be 20 t minus half squared negative 5 plus 120, it's going to give us positive 115. This is our final answer. So if we look at our final answer here and then we look at the standard form equation, we can see that we have finally written our quadratic equation in standard form. Now, the thing that we are most interested in here is our h and k. And if we look at our final answer, we can see that our h is half and our k is 115. Therefore, our vertex is going to be equals to half, which is 1 over 2, comma, 115. So our h is half and our k is 115. Then if we look at what C was saying here, at what temperature would the number of bacteria be minimal? So remember what we said up here. We said that h is the vertex coordinate that represents the temperature. And because h is equals to 1 over 2 here, when we look at the vertex coordinates, we know that the temperature that will give us the minimal number of bacteria is 1 over 2 or is half. So T is equals to 1 over 2 degrees. This is our final answer. And now we might be asking to say, okay, how about this 115 over here? This 115 or the coordinate K is the lowest number of bacteria that we can get. And this only happens when the temperature is at 1 over 2 degrees. So this is how we can interpret everything that we have done here. However, since the question is asking us to find the temperature at which the number of bacteria will be minimal, our only interest is the value of H. Hence, our final answer is 1 over 2 degrees. If you're struggling to understand math and you know that you need help, please feel free to sign up for our math tuition classes by scanning the barcode that you can see on your screen right now or by registering using the link in the description below. Alright, so now we're going to look at question 4. Question 4 here reads, the profit function in dollars per day for a small scale company is given by f of x is equals to negative 16x squared plus 64x plus 190, where x is the number of products sold each day. Find the number of products x sold each day in order to maximize the profit and find this maximum profit. So when we look at the question here, we have our function, which is given by negative 16x squared plus 64x plus 190. Let's actually write it down in advance. So f of x is equals to negative 16x squared plus 64 plus 190. And then it goes on to say x is the number of products sold each day. So x is equals to number of products sold each day. And then the question now goes on to further tell us to say find the number of products x sold each day in order to maximize the profit and find this maximum profit. What the question actually is asking us to do here is to find that value of x that equals h, and then once we find this value that equals h, we are going to use this value to find the maximum profit, which is k. So our k is our maximum profit. So when we find h, we find the number of products sold each day in order to maximize profit, and then we use this same value of h to find the maximum profit k. Now let's begin solving our question. So we're first going to start by getting our a, b, and c. Our a is equals to negative 16, our b is equals to 64, and then our c is equals to 190. So you don't always have to do this in your final answer booklet, so you can always do this on a rough paper. This is just to show you some of the things that you need to basically consider when you're solving questions like this, to just help you remember the important aspects of the question that will help you solve the question correctly. So our a in this case has a negative sign in front of it. As we can see here, we have a negative sign in front of 16. This means that the graph of this function right here is going to open downwards, and this means that the vertex of this graph is going to be the highest point of the graph, and we know that the highest point of the graph is right here in the middle at the top. Therefore, this is where we're going to find our h comma k. Now that we have that out of the way, let us solve our question using the first method, which was completing the square. So the first thing that we're going to do is write down our function once again, so that we have f of x is equals to negative 16x squared plus 64x plus 190. Forgot to write down an x here as well. So now that we have our function written down, the next step is going to be to factor out a from the two values that have the variable x in them. And we know that a is negative 16, so we're going to factor out negative 16 from the two values that have the variable x in them, so that we say negative 16 into negative 16x squared, which will just give us x squared, and then negative 16 into 64x will give us negative 4x. So we have 190 here. Our next step will be to deal with b. We are going to half b, which is the same as just saying b over 2 or b times half. So this is just one and the same thing. Okay, so after factoring out negative 16, we know that our b has become negative 4. So we're going to half negative 4 either by dividing it by 2 or by multiplying it by half. Either way, it's going to give us negative 2. So negative 2 is the half of negative 4. And then the next thing that we're going to do is we're going to square this negative 2 so that it becomes negative 2 squared. After squaring it, we're then going to add it and subtract it. So we're going to have negative 16 x squared minus 4x plus negative 2 squared minus negative 2 squared and then plus 190. So what we have here is just the same as this, no difference. We can see here that we've halved our b and then we've squared it and then we've added it and also subtracted it at the same time. The next thing will be to simplify this further so that we have negative 16 x squared minus 4x plus 4, negative 4 here, plus 190. So that's what we have here. The next thing that we're going to do is take this negative 4 outside the parenthesis. In order for us to do that, we're going to have to multiply this negative 16 by this negative 4 and then put it on the outside of the parenthesis so that we can simplify it together with the 190 on the outside as well. So we're going to have negative 16 x squared minus 4x plus 4. We're taking the negative 4 outside. We're going to multiply it by 16 times negative 4 plus 190. To simplify it further, we're going to have negative 16, and we know that inside our parenthesis here we have a perfect square. Then we're going to have x. We know that x times x is equals to x squared. So this is why we're writing down x here, because we're simplifying the perfect square. Then the next thing is going to be to omit the negative 4x. So we're going to focus on the positive 4. And then when we look at the positive 4, we're only going to concentrate on the value that multiplies with itself in order to give us this positive 4. And we know that that value is negative 2. So we're going to write down negative 2. And then we're going to close the parenthesis. Then we're going to put our exponent here, which is 2. Everything that we have here is the same as everything that we have inside here. If we were to multiply x minus 2 times x minus 2, it's going to give us everything on the inside here. So we've simplified our perfect square. The next thing will be to simplify everything else at the end here. We know that negative 16 times negative 4 will give us a positive 64 plus 190. If we're to simplify this further, we're going to have negative 16x minus 2 squared, and then at the end here, when we add 64 and 190, we're going to have plus 254. So this is our final form, or rather this is our standard form of the quadratic function. F of x is equals to negative 16x squared plus 64x plus 190. So from this standard form, what we're interested in are the coordinates of the vertex. So we know that the vertex is going to be equals to h comma k. If we were to pick out our h and our k from the standard form, we know that our h in this case is 2, and then our k is positive 254. So we're going to have 254. So these are the two coordinates of our vertex, and our vertex in this case, like we mentioned earlier, is the highest point of the graph of the quadratic function negative 16x squared plus 64x plus 190. So the number of products sold each day in order to maximize the profit is our h, and we know that our h is equals to 2. Therefore, the number of products sold each day, x, is equals to 2. Now we need to know what our k is, and we know that our k is the highest point on the graph of our quadratic function. Therefore, 254 is the maximum profit that we generate each time we sell 2 products each day. Because remember, we need to sell 2 products each day in order for us to maximize profit. Therefore, when we sell 2 products, we generate a maximum profit of 254 each day. So we're going to say our maximum profit, we're just going to say MP here, is equals to 254. So you can put the currency of your choice here, whether you want the dollar or the kwacha, it's up to you. So $254 is the maximum profit that we generate each time we sell 2 products each day. So these are our 2 answers. If you're struggling to understand math and you know that you need help, please feel free to sign up for our math tuition classes by scanning the barcode that you can see on your screen right now, or by registering using the link in the description below. Thank you very much. We have come to the end of our lesson today. See you in the next video.
Can you be my tutor? Walk on a